Hello, Algebra 2 students. This is a lecture on solving polynomials. I'm calling this section 5.6-ish because it is part of 5.6, but it also has even some ideas from 5.5 and 5.7 in it. And so I'm kind of making my own section with the intent that by the end of it, you guys will be able to solve polynomials. Now, this is going to utilize some ideas that we needed in the past. One of those ideas is going to be this here. Remember that the degree of the polynomial is the number of solutions that that polynomial has. So if you have a quartic, remember quartic means its biggest exponent is to the fourth power. That means that you need to find potentially 4 solutions, or you should be finding 4 solutions if you are asked to find all of the solutions for that polynomial. That's going to be true, if it was x to the 7th minus 6x to the 3rd plus 2x minus 8. And you, for some reason, were asked to solve this polynomial, you would be needing to find 7 solutions because that's the degree that tells you how many solutions it has. We're also going to need to know how to use synthetic division. If you don't remember how to use synthetic division, go back to the 5.5b lecture where you can get a reminder on how to use synthetic division. Okay, first type of question. I'm going to give you a polynomial, and I'm going to ask you to pick which one of these happens to be a factor. Now, if a binomial or any polynomial is a factor of another polynomial, that means that when you divide it, it should have 0 for its remainder. So I don't know which one of these is a factor by looking at it, but I can figure it out pretty easily. It might take me 2 attempts, but that's what it would take. What I'm going to do is I'm going to use synthetic division with this guy here. And I'm going to say, hey, is this the factor? And what will tell me is if when I divide using synthetic division, if I get 0 out at the end, okay? Because in order to be a factor, its remainder would have to be 0. So remember how you use synthetic division. You look at the binomial and you say, what makes it 0? That would be -1. And then all of the coefficients here, 1, -4, -12, 1, and -6. So what I'm looking for is 0 there. If 0 is there, it's a factor. If it's not, then it's not a factor. So I'm going to drop 1, multiply them, -1. -5, remember how we're doing this, multiply, that would give you 5. And then -7, and then 7, and then 8, and then -8, and then -14. Okay, we did not get 0 here. So x plus 1 is not a factor of this polynomial. Based on the question, I'm guessing that x minus 6 is a factor. If x minus 6 is a factor, then 6 should give us 0 out at the end. 1, -4, -12, 1, and -6. 1, 6, 2, 12, 0, 0, 1, 6, 0. So that did actually work, correct? My remainder is 0. Therefore, I know that x minus 6 is a factor. One thing that I want to point out right now, and this is going to be a really critical moment of understanding for you. So based upon 5.5, we know that when you divide this polynomial by x minus 6, our answer is kind of tucked here. That one's the remainder. This one gets no x. This one would get an x. This one would get an x squared. And this one would get an x cubed. So when we divide this polynomial by x minus 6, our solution was x to the 3rd plus 2x squared plus 1. Based upon the idea of multiplication and division and how they work with one another, what that means is this binomial multiplied by this cubic here, right, this trinomial, should equal x to the 4th minus 4x to the 3rd minus 12x squared plus x minus 6. You guys believe that? Because that's how division and multiplication work together. If I were to take this polynomial and divide it by this one and get this, that means this times this should get me back to where I started. Multiplication and division are inverses of each other, right? Or, if we were looking at this as, hey, this is a polynomial equal to these. If I divided both sides by x minus 6, this should cancel. Divided both sides by x minus 6, right? So this divided by x minus 6 gave me this statement. So I just really want to take a moment to kind of understand what's happening there. Is when you divide x minus 6, when you divide this by x minus 6 and you get this answer, that's also telling you that this answer times x minus 6 should get you back to where you started. That's how multiplication and division work. Go ahead and try this one. Pause it. Make sure you get the right answer. I'll go ahead and do the same actually. -5, 1, -10, 2, -19, and -10. And then I'll also be doing, actually this should have been x plus 10, I believe. We'll see. We'll see if x minus 10 if 10 is a factor, and if it's not, I'm guessing it's -10. So drop 1, -5, -15. I can already tell my numbers are going to be way too big. 65, we're not getting back to 0. So I can already tell that this one's not. If you continue on with it, that's totally fine. 1, -10, 2, -19, -10. 1, 10, 0, 0, 2, 20, 1, 10. Okay, that did work. So x minus 10 was the factor. Very cool. All right, so this question is looking a little different. I give you a polynomial, and I also tell you that x minus 4 is a factor of that polynomial. And then it says to completely factor it. Well, at this point, you guys don't know how to factor this statement. Okay? If I had told you guys previous to this to factor x to the third minus 6x squared plus 5x plus 12, the only thing that you guys would have known to even attempt was to factor by grouping. And if we were to factor this by grouping, because that's what I've told you guys to do if you have 4 terms, right? Try factoring by grouping. If you were to try factoring by grouping, these have an x squared in common, and when you take out an x squared, you get x minus 6. And these don't have anything in common, so then it would be plus 1, and then in parentheses you'd have 5x plus 12. Because these don't match, you can't factor this by grouping, so you would have been stuck. However, given what we know, we actually do have a way to factor this completely now. And guess what? It involves synthetic division. So we're going to divide by x minus 4. Remember, if we divide by x minus 4, that means 4 is going to go on the outside. And we're going to take this statement, all the coefficients, 1, -6, 5, and 12, and use synthetic division. Because it's a factor, we better get 0 right here. Not here, here. If we don't get 0 there, something is amiss. So let's try it. Drop the first number down, 1. 4, -2, -8, -3, -12, 0. We did successfully get 0 there. So what we're really saying here is that x to the third minus 6x squared plus 5x plus 12 divided by x minus 4 is equal to, okay, here's our remainder. We don't need it. This one gets no x, this one gets an x, this one gets x squared, is equal to x squared minus 2x minus 3, right? We took this statement, divided it by x minus 4, and our answer was x squared minus 2x minus 3. We could also state that if you multiplied by x minus 4 here, multiplied by x minus 4 here, this is also a true statement. X to the third minus 6x squared plus 5x plus 12 is equal to x squared minus 2x minus 3 times x minus 4. Well, we've already almost completely factored this. If I can factor this statement here, then I will have completely factored this. And this is factorable. If we factor this using the traditional method, this would come out to x minus 3, x plus 1, x minus 4. And that is completely factored. Keep in mind, if this was set equal to 0 and you were asked to solve it, we would also be able to solve it. 4 would have been an answer, -1 would have been an answer, and 3 would have been an answer. And how many solutions would we have been looking for? Well, the degree of the polynomial, which is 3. So this is a really pivotal step in solving polynomials. Okay, granted, we had to be given a little bit of information about it, but once we were given information about it, we were able to go the rest of the way. We just divided it by that and then looked to factor the statement here. Let's try another one, very similar. Once again, you could have tried to factor this by grouping right away, but you would have gotten stuck. Instead, we're given that x plus 2 is a factor. So I'm going to take this polynomial and divide it by x plus 2. When I divide that polynomial by x plus 2, remember I'm putting whatever makes it 0 on the outside, and then 3, -4, -28, and -16. The coefficients go in the first row. Now I'm just going to do some synthetic division. -10, those multiplied to 20, -8, 16, and 0. So yes, I did indeed confirm that x plus 2 is a factor because I got 0 at the end. Now I can rewrite this polynomial as no x squared as 3x squared minus 10x minus 8. So this quadratic times this linear equation would give me this, right? That's what it means inherently because it's a factor. It actually gave us 0 out. So when I took this statement and divided by this, I got this. That tells us that this times x plus 2 would give us back to the beginning. We were told to completely factor this, and we haven't completely factored it yet. We need to try to factor this guy, and this is the box method question, right? Because there's a number in front of x squared, that tells us that we need to use the box method. How you use the box method, this number goes in the first box, -8 goes in the last box. Multiply them, you get -24, and the factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Actually, multiple of these factors get us to -10. -12 and +2 would get us to -10, and -4 and -6 would get us to -10. Which of these multiplies to -24 though? That would be that one. Right? -4 times -6 would have been +24, not negative. So these are the things that go in these two boxes. It doesn't matter the order. We're going to have a 2x and a -12x. What's common between the top two boxes is an x. 3x here. We should be really good at factoring using the box method at this point. And 2. 2 times -4 is -8. So this statement here factors to 3x plus 2 and x minus 4. This is also a factor. So our completely factored polynomial would be right there. Also keep in mind, if you were asked to solve this, you could. -2 would be a solution, -2/3 would be a solution, and 4 would be a solution. You just set each of these equal to 0 and solve them. This one looks fun. Find the 3 solutions if you know that -4 is a solution. So this time it didn't tell me what was a factor. It told me what is a solution, which isn't that big of a deal. Because if -4 is a solution, that tells me that x plus 4 is the factor that goes with that solution, right? Because -4 makes this 0. So it's like I'm dividing by x plus 4. Well, when you use synthetic division with x plus 4, what goes on the outside? -4, right? So I can go ahead and use synthetic division with -4 right now. 2 is going to go here, and then 3, and then -27, and then -28. It then remember, anytime you're missing a term, you do have to put 0 in as a placeholder. We're missing the term, the constant term, the one that doesn't have an x. So I'm going to go ahead and do synthetic division, -8, -5, 20, -7, 28, 0, 0, 0. So if -4 wasn't a solution, we wouldn't have gotten 0 out. But because -4 is a solution, we get 0 out at the end. That first 0 is our remainder. This is the plane without an x term. This one gets an x, this one gets x squared, and this one gets x to the third. So in our journey we're trying to find the other 3 solutions. In our journey to find the other 3 solutions, we know that this original polynomial factors to x plus 4, which gives us the solution of -4, the given one. And the other ones are going to come from 2x to the third minus 5x squared minus 7x. And we are trying to solve this. Now, this isn't looking super pleasant at this time. However, we do know from a previous lecture that because these all have an x in common, we should be able to factor that out. And when we factor that out, we can actually write it all the way in the front. So it would be like this, x, okay, because everything has an x in common, we're going to undo the distributive property. And when we undo the distributive property, it would give us this. And then we're going to continue on working with this statement. That x just got written out front. We have 2x squared minus 5x minus 7. So we have now found one of the solutions, right? We knew -4 was a solution at the beginning, and we can think about what makes this 0, and that's just the number 0. So now we have 2 of the solutions, but we are still looking for 2 more, right? Because it said, we know what -4 is, find the other 3. So we found 0 as one of them. Now we need to solve this equation, but thankfully we have something that solves any quadratic. So if you ever get down to a quadratic, you can always solve it using the quadratic formula. I'll first try to factor it. I'm skeptical if factoring is going to work. Let's try it. 2x squared and -7. When you multiply those, you get -14, and then you list the factors of -14. Oh, it does look like it's going to work. 1 and 14 and 2 and 7. Do any of these factors potentially get you to -5, -7, and +2 does. So those are going to be the 2 numbers that go in the second and third boxes. We'll put a 2x in one and a -7x in the other, and it really doesn't matter which one goes where. So what's common between the top 2? That would be 2x, and then the rest kind of completes like a multiplication table. 2x times what is 2x squared? That would be x. 2x times what is 2x? That would be 1. -7, those do multiply. So this factors then to 0 equals x times x plus 4 times x plus 1 times 2x minus 7. We were asked to find the solutions. The solutions are 0, -4, -1, and whatever makes this 0. If we don't see it, don't be afraid to just set it equal to 0, add 7, divide by 2, we get 7/2. So that's a lot of work. There's a lot of challenging ideas in this, but those are our 4 solutions to this polynomial. And I think that's kind of exciting that we can now take a polynomial like this and find the solutions. This is a challenging problem here. Once again, it has 4 solutions because that's the degree of the polynomial. And we are given one of them. We're given that -1 is a solution. We know that if -1 is a solution, then x plus 1 is a factor. So I already know one of my factors. I'm going to divide by x plus 1 to find the others. And when you divide by x plus 1, -1 is what goes on the outside. So 1, 3, -3, -15, and -10. Going through the synthetic division process here. What we are left with is this one. 0 tells us that -1 is a solution, or that x plus 1 is a factor, because our remainder was 0. This one gets no x, that one gets an x squared, and x to the third. So x plus 1 is a factor, we knew that. And then the rest is going to be x to the third plus 2x squared minus 5x minus 10. We're trying to solve this polynomial. So it's set equal to 0. We need to figure out what values of x make it true. And if you put on your thinking caps here, we don't have a great way to solve x to the thirds. Okay. There was one thing that I told you guys, that if you guys do come across a polynomial with 4 terms, there is a way to factor some of them, and that method is factoring by grouping. Let's go ahead and try it. So let's group the first 2 together. X to the third and 2x squared do have something in common. That something in common is x squared. And if we take an x squared out of them, you'd get x plus 2. These two have a 5 in common, and because our term is negative here, let's factor out a -5. And if you factor out a -5 here, -5 times what is -5x? That would be x. And -5 times what is -10? That would be +2. So our parentheses match. That tells us that we can continue with factoring by grouping. And what you're instructed to do is take these 2 things and write those out front. X plus 2 just becomes 1. And then x squared minus 5 goes in parentheses here. So our solutions are -1, -2, and whatever makes this one 0. Now this is not factorable, but it is something we can solve. We can just set that equal to 0 and solve it. Add 5, x squared is equal to 5. Take the square root of both sides. X is equal to plus or minus the square root of 5. So our solutions are -1, -2, and plus or minus the square root of 5. And truthfully, that is as complicated as Chapter 5 can get. For us, now I know that that's a lot, but it does incorporate some ideas. It incorporates a lot of ideas. We've got synthetic division. We've got factoring by grouping. We've got solving quadratics in non-traditional ways, all in one problem. So that is a lot. This is the last problem we're going to do, and this one is also fairly difficult. It says that we need to find the remaining 2 solutions given that x minus 2 is a solution. Remember, if x minus 2 is a solution, that tells us that x plus 2 is a factor, because -2 would make that 0. So we need to divide by x plus 2, or put -2 on the outside. 1, -4, -2, and 20 go here. We're going to go through the synthetic division process. 1, -2 would give us -6, 12, 10, -20, and 0. Yay, we got 0 at the end. That tells us that -2 is in fact a solution. This one gets no x, that one gets an x, that one gets an x squared. So this factors to x plus 2, x squared minus 6x plus 10. And we were told to find the zeros, or the solutions. What makes it 0? We know -2 is one of them, but we need to take this quadratic and solve it. I would love it if this was factorable, 1 and 10, 2 and 5, but none of these are getting you to -6. And so we just need to use the quadratic formula, and that will tell us what the 2 solutions are to this equation. So let's go ahead and do that. Remember, the quadratic formula is -b plus or minus the square root of b squared minus 4ac over 2a, 6 plus or minus square root of -6 squared minus 4 times 1 times 10 all over 2 times 1. Carrying on, 6 plus or minus the square root. I've instructed you guys to just type everything underneath the root in your calculator and see what you get. I'm going to do that right now. Making sure to put my -6 in parentheses, -6 squared minus 4, 1 times 10, you get -4. What is the square root of -4? Remember, anytime you're taking the square root of a negative, we no longer get no solution. The square root of a negative just creates an I. So then you just have to take the square root of 4, which is 2, 6 plus or minus 2i over 2. I can actually divide both of these by 2 to get 3 plus or minus I. So I was instructed to find the other two solutions. And those other two solutions are 3 plus I, 3 minus I, and then the original solution was -2. So that is section 5.6. That is our finale for chapter 5. Please make sure you're practicing these. Please ask questions when you get stuck, because you probably will. This is a difficult section. And let me know what questions you guys have. Thank you.